Needless to say, there are many different ways to evaluate interactive systems. We will cover several representative approaches in this unit, but it is important to remember that these are just a small selection of the many approaches that have been developed. Evaluation itself can involve many different people, from designers and evaluators through to actual users of the system. It is important to be clear that, in an evaluation, there are people conducting the evaluation, evaluators, and usually people participating in the evaluation, subjects, potential users, evaluators, or even in some cases no one. In order to give some idea of the variety of techniques available, we shall consider evaluation in terms of the kinds of people participating in the evaluation, from users to evaluators, and finally to techniques that do not rely on anyone physically using the system. Evaluation with users. We are interested in evaluating systems which will be used by users, so why not test the systems with people who are likely to use them? Such evaluations are the focus of this section. User observation. In order to discover usability problems with user interfaces, we can observe users attempting to use them, in which case the users are the subjects of the observation. Typically, users are given tasks to perform with their user interface. These are the tasks the user interface is intended to support and then asked to attempt to complete them. Whilst using the system, the users are observed through a number of various techniques, as outlined below. It is important to remember that we are interested in problems. The idea to tell subjects this before they start the test so that they realize that it is the interface that is being tested, not them. As the idea behind this approach is to see how potential users will react to a system, it is important to select appropriate users as subjects. They should be typical of the target population for the system. For instance, evaluations of cash machines will require any subjects who have, or could have, a bank set of subjects, those with appropriate medical training, e.g. specialist nurses. Subject selection should be done before the evaluation to ensure subjects have the appropriate experience and knowledge. A simple questionnaire, see later discussions, can be used at the start of the evaluation to check that subjects are appropriate. Firstly, users may be directly observed. The evaluator watches what their user does and notes down pertinent points. Clearly, the evaluators may miss important information as their user carries out their task. To address this problem, sessions are usually video recorded, focusing on the important parts of the activity, such as screen display and slash or mouse movements. These video recordings can then be reviewed later and interpreted at length. Several off-the-peg kits have been developed, which comprise of multiple video cameras, video and audio mixing facilities, video recorders, tripods, etc. These are different locations. These video recordings can often be used in conjunction with logs of use of the system generated by the system itself, a time-stamped list of the actions the user performed, e.g. pressing a button, moving the mouse to a particular position. If evaluation is being undertaken early in the design process, it is likely that not all of the underlying functionality has been developed, e.g. speech recognition. An approach to address this issue is referred to as Wizard of Oz, and dates back to the early development of user interfaces. The term comes from the film of the same name, in which the wizard gives the impression of being very grand and powerful by communicating through a huge contraption. Similarly, in interface design we can fake interaction by using larger computer systems to perform the operations, or utilize even more powerful systems, human beings. In the early days of computing, PC designs were tested by performing operations on mainframes, but giving users the impression that the PC was providing the functionality. Nowadays, we might wish to fake natural language processing in prototypes by having a person type replies to a 5.4130.9 subject, which are displayed via processing being performed by the computer, as illustrated in the following diagram. The subject asks system presence to the user as its own output. Clearly, this is futile if we are trying to evaluate natural language software, but it can give us insights into how such systems might be received by users. However, the more complex the observation becomes, the more it intrudes upon the user and may affect their performance, so skewing the results of the evaluation. Sophisticated observations often involve the use of one-way mirrors to hide the observer and their equipment from their user. Furthermore, the user may be placed in a setting similar to their normal working environment to make them feel more at ease. Alternatively, observations can be carried out in the workplace itself, which gives well-grounded results, but can often be difficult to set up, especially in busy working environments where the subjects may be interrupted. Simply observing the user attempting to perform tasks may not tell us enough about the problems they are encountering. Unlike computer-generated logs, we cannot at present easily get a direct log of their actions and intentions. Instead, we have to rely on the user telling us what they were doing and why. Two approaches to generating a protocol of the task description of what the user does and why are possible. Concurrent protocol: the user says what they are doing and why whilst they are performing the task. Retrospective protocol: the user tells you what they did and why after they have finished the event. This may be done in conjunction with a transcript of the task performance and or a video recording. Choosing which approach to take is not an easy task in itself. For instance, asking the subject to verbalize their every action and intention may distract them from performing the task itself. On the other hand, subjects may not reliably remember what they did or why they did it in a retrospective protocol. Moreover, retrospective protocols rely on subjects being prepared to stay after they have performed the task to further discuss their actions. How many people would be prepared to do that? User feedback. After subjects have used a system observed or not, plenty of useful information about its usability can be obtained from the subjects themselves. Two methods are considered here: interviews and questionnaires. Interviews, observing the use of a system, can give us some idea about what happens when the systems are used, how they felt using the system, whether they would like to use such a system, etc. In interviews, we attempt to find out how the subjects felt about the system, their subjective opinions. Typically, an interviewer asks an interviewee a set of questions about their experience of the system. These questions may be structured in several ways. Structured interviews: the questions are defined beforehand and are the only questions asked, thus provides a set of answers which can be compared across several subjects. Unstructured interviews: some set of topics of interest into the evaluation are defined, but the interviewer is free to choose which topics they ask, in which order, and how much they explore the topics. This approach usually does not give as easily comparable results as structured interviews, but it can be useful in identifying requirements. These are useful situations in which the full evaluation criteria are probably not well defined yet. Semi-structured interviews are predetermined set of questions with the flexibility to pursue topics further if they seem interesting. Card sorting: this technique is quite different from the others. Instead of being asked questions, the interviewee is given a set of paper cards with some aspects of their user interface or task written on them. They are then asked to sort the cards into groups, typically groups of similar items, an interface and or the task. This perception might be quite different to what the designers envisaged. When designing an interview, the interviewer must take into consideration not to tire the interviewee. The interview should carefully constrained. This will also save the interviewer from spending a substantial amount of time conducting the interviews, as well as later transcription and analysis time. Questionnaires. Unlike interviews, questionnaires involve subjects filling in responses to questions themselves, rather than responding to an interviewer. Therefore, questionnaires can typically involve a larger set of people, as there is no need for the interviewer to ask each subject for their answers. Indeed, extensive use of questionnaires is usually referred to as a survey. As with interviews, questionnaires need to avoid being too long and time-consuming. In addition, they need to be designed to ensure enough subject response. As a rule of thumb, questionnaires should be kept within 2 sides of A4 and some sort of incentive will probably need to be given to encourage potential subjects to complete it. There are two main types of questionnaire: open questions and closed questions. Open question is where the subject is free to write their answers in any way they see fit. Of course, this means that analysis time must be devoted to trying to understand what subjects meant by their answers, and moreover, subjects may not provide appropriate answers at all. Closed questions is where the subject selects an answer from a set of presented possibilities. This provides less ambiguous results than open questions. Closed question questionnaires rely on some way for the subject to select between alternative possible responses. Priest 1995 identifies several kinds of scale from which subjects can choose their response, including simple checklist, multi-point rating scale. A number of points on a scale are provided which give a range of responses. Ranked order: rather than giving the subject a scale from which to pick their responses, this approach requires the user to specify their preference for items in a list. User experimentation does not refer to do experiment on users, but rather performing experiments in which subjects participate. Instead of simply giving users tasks and observing how they perform them, experimentation is concerned with attempting to provide some empirical evidence to support some hypothesis. In the case of user interfaces, a hypothesis is usually some supposition that one user interface will be better than another in some respect. Essentially, an experiment involves two sets of users whose situation differs in only one respect: that which is being tested. For example, in an experiment to determine whether a trackpad is quicker to use than a mouse for selecting objects on the screen, the two sets of subjects would be treated identically, except that one set would use a trackpad and the other a mouse. This simple example highlights many aspects of experimental design. First off, the hypothesis is some prediction. We wish to test here that a mouse will be quicker to use than a trackpad. This has itself probably been derived from some previous research or observation. Secondly, we need to be explicit about what kind of difference we expect to see. This is the thing we are going to measure in the experiment, and is referred to as the dependent variable. In this case, it is the time to complete tasks. With a computer, the prediction was that using a mouse would be quicker than using a trackpad. Thirdly, we need to state what we are going to change between the different sets of subjects. The thing that we change is referred to as the independent variable. In this case, it is the kind of input device used, either a mouse or a trackpad. Usually, in experiments to do with user interfaces, we keep the task the same across all subjects so that we can determine the difference between user interfaces for the same task. Therefore, it is important to select tasks which can be performed using the different user interfaces. Finally, it is important in experiments to avoid confounding variables. These are things which are beyond your control and might affect the result of the experiment, and should therefore be avoided. In this case, the fact that most users of computers currently use mice rather than trackpads could be a confounding variable, as the subjects would be more experienced with a mouse, and so probably quicker by default. In order to remove this confounding variable, we could select only novice computer users for the experiment. As mentioned previously, independent variables are the factors that we change between sets of subjects. Previously, we considered the type of input as an independent variable, either mouse or trackpad. These are levels of the independent variable. In this example, there are two levels of the independent variable, but more complex experiments may involve more than two levels of independent variable, and may also involve more than one independent variable. Each unique combination of independent variable levels is referred to as a condition. So, for our simple example, there are two conditions in the experiment, one where subjects use a trackpad, and another where they use a mouse. If we were to build on the design of this simple experiment by including another independent variable, we would increase the number of conditions in the experiment. The following table illustrates how these two independent variables and their levels combine to produce 6 conditions in the experiment. Dependent variables. Dependent variables are those things that we are trying to measure to support or disprove our hypothesis. Therefore, they need to be things that are easily observed and measured, for example, the time it takes to complete a task, the number of errors made during the experiment, the time taken to recover from an error, number of times help is used, length of time help is used for, time spent before response is formulated. The dependent variables above. Quantitative data, i.e. numerical results. Qualitative data, such as user preference, can be gathered using interviews or questionnaires, as discussed previously. Assigning subjects. Recruiting enough subjects is one of the hardest parts of conducting an experiment. Typically, at least 10 subjects are needed per condition to provide statistically significant results that we are pretty sure could not have happened by chance. For the more complex experiment proposed previously, this would require 60 subjects, and per condition attracting so many potential subjects usually requires some incentives such as cash or unit credits for students. The use of each subject in only one condition is referred to as between groups design. We can reduce the number of subjects needed by reusing subjects in different conditions referred to as within groups design. However, subjects may then carry over experience from one condition to another, and so introduce a confounding variable into the experiment. Statistics. We use statistics to determine whether an independent variable such as the kind of input device has an effect, positive or negative, on a dependent variable such as the time to complete a task, and that this has not come about by chance. A thorough coverage of statistical analysis is outside the scope of this unit. Suffice to say that we are looking for results that are statistically significant. That is, we believe that they did not occur purely by chance. In order to address the problem of costly evaluations involving tens or hundreds of users, Molich and Nielsen 1990 devised a technique called heuristic evaluation. In their approach, a heuristic is a usability principle against which the system is evaluated by trained evaluators. They initially considered 10 heuristics, but later went on to refine them further. In an evaluation, there are typically 3 to 5 evaluators who each assess the system, or a prototype of it, against the 10 heuristics. Before performing the evaluation, all the evaluators will need to be trained in terms of the evaluation technique and the tasks that the system is supposed to support. The evaluation itself usually involves working through a scenario of use, an example task that users might perform with the system. In order to identify problems thoroughly, the evaluators usually work through the scenario twice, once to get an overview of the system, and the second time to assess the usability in depth. After they have completed the evaluation, the lists of problems found are compiled into a coherent set using multiple evaluators, means that there is more chance of identifying a coherent set of problems, as each evaluator probably perceives problems slightly differently. The problems in the collated set are then rated according to a severity scale discussed later. Finally, the problems found are fed back into design to improve the next design of the system. As discussed earlier in the unit, this form of iterative prototyping and evaluation works best if the evaluation occurs early in the development process, before too much coding time has been invested in the system. Heuristics. The first set of heuristics developed for heuristic evaluation are listed below. Typically, the evaluator would work through the given scenario, trying to decide whether the heuristics were violated or not. 1.1 Simple and natural dialogue. Is the interaction with the system clear and concise? 1.2 Can the user understand the information presented to them? E.g., is there too much jargon? 1.3 Does the system rely on users remembering complex or meaningless pieces of information? e.g. pressing Ctrl plus Alt plus Del is a pretty meaningless way to bring up the task manager for a novice user. Another example might be a system in which users cannot copy information from one window to another. Therefore, systems should be designed another reason for more iterative prototyping. 1.4 Consistency. Do things happen differently in different parts of the system? E.g. the operation to save a file should be named consistently in different parts of the system, not save in one part and write in another. 1.5 Provide feedback. Does the system inform the user about what is happening? E.g. highlighting buttons when pressed is good feedback, as is showing an hourglass when the system is busy. 1.6 Clearly marked exits. Can the user easily abort an operation? E.g. in wizards there should be some way of escaping from the sequence determined by the wizard, and it should be obvious how to do it. 1.7 Provide shortcuts. If the user becomes an expert, will they be able to use shortcuts to speed up their performance? E.g. providing keyboard-based shortcuts for menu items. 1.8 Precise and constructive. Error messages. Just telling the user that there was an error does not help them to understand the system. Does the system explain why there was an error and what could be done about it? 1.9 Prevent errors. If possible, does the system prevent users from making errors? E.g. if a field requires only numerical data, does the system prevent the user from entering letters? 1.10 Adequate help and documentation. Could the user work out how to use the system from the help and documentation provided? Severity ratings. As we mentioned before, once the usability problems have been identified using the heuristics, the severity of the problem is rated. Rating is done individually by evaluators, and then, as with the problems, the ratings are collated to get the consensus opinion. Revised heuristics. As mentioned previously, the initial set of heuristics were refined after extensive use. These refined heuristics are discussed below. Note how some of the heuristics have remained. 2.1 Visibility of system status. Does the system keep the user informed about what is going on? E.g. indications of